Today we're going to talk about 21E, interpolation and extrapolation. So interpolation is predicting y values inside of the values of x we have in our data set. And extrapolation is predicting y outside of the values of x we have in our data set. Here's kind of a little picture to help represent it. So the black dots represent the data. Then we have two things, the two poles. We have a lower pole and an upper pole. The lower pole is the furthest left point, so the lowest x value we have, and the upper pole would be the furthest right point, which is the largest x number that we have. All right, so then if we predict y values, our dependent variable, with an x that's inside this range, that's interpolation. And if we try to predict with an x value out here what y would be, that's extrapolation. Now, when we predict inside, our data is there. It's probably going to be fairly accurate. But when we get outside of where our data is, out here or out here, it may not be the most accurate prediction because all of our data is here. So if we go far to the right or far to the left of our data, it may not be that accurate. So here's a little example. So as you can see here, the example deals with time spent on class per day in minutes and your grade in the class in percent. There are your data values. So first step is we're going to make a scatter plot of the data, find the least squares regression line, and find the correlation value. All right, so I'm going to pull up the calculator here. Remember to do the least squares regression line, correlation, scatter plot, everything like that. You need to put your data into lists. So to do that, you go stat edit. I've already put the data in here just to speed up this video a little bit. Once you've done that, so list 1, list 2, stat, calculate, linear regression. Now here's the key. You need to make sure your X list is the list that it says, list 1. Your Y list is the list it says. And I'm also going to store the regression equation in a Y equals. To do that, you click vars, go over to Y vars, Y variables. It's a function, and we're just going to store it in Y1. Then you go to calculate, and you have all this information. We're going to talk about these values for a little bit. So y equals ax plus b. A is your slope. So what does that mean in the context of this problem? It means that for every increase of 1 minute that you spend, your percent in the class is going to go up by 0.67. And then your b is your y-intercept. Now, what does that mean in the context of this problem? It means that if you were to spend no time on the class, you would have a 50.8%. Now, sometimes the y-intercept makes sense in the problem, sometimes it doesn't. This one, if you don't spend any time on the class, you're probably going to get lower than a 50%. Then our R value, our correlation coefficient, is 0.9698, which means the points pretty much form a line. There is a very strong linear correlation between the two. Then to make a scatter plot, first thing you'll notice, if you go to Y, it automatically puts that equation in there. That's what we did when we stored the equation. But then if you hit second y equals, we get to the stat plot menu. We turn it on. It's a scatter plot. We want to make sure our list 1 and list 2 is what we're using. We hit graph. If your screen, it doesn't show up in your screen, make sure to do zoom 9. which is zoom stat. It'll make the line with the points right nice on your screen for you. So as you can see, the lines or the points pretty much form a line. That's why our correlation is strong. So that was A. Now B says, predict the grade of someone who spends 36 minutes a day on class. So you could do that by hand, by plugging in 36 for X, and then just solving with your calculator. Here's a way to do it with your calculator where you don't have to do much work. So where you want to calculate a value, so to get there I went second trace, and we want to know what Y is when X is 36. So when our prediction, if we spend 36 minutes on class, our grade will be a 74.98 as a percent. As you notice, that what we just did was interpolate. We predicted what our percent was going to be inside of our data points. So if we had a 36, we would predict like about 75%. Now C says, predict the grade of someone who spends 120 minutes a day on class. Now, if we go to calculate again, X equals 120. It's not even going to do this for us right now because 120 for X is not in our window. We're outside of our data range. This is extrapolation. But if you want to do it with the calculator, you could zoom out a couple times. And now I bet 120 is in here. So second trace value. There it is. So this is saying, using our linear regression line, if we spent 120 minutes on class, 2 hours, we would have 131.44%. This is extrapolation because you see all our data points are right here. We predicted outside. So this probably isn't a very accurate unless Mr. Natsky is super nice and gives you a ton of extra credit for spending extra time on class. But probably this 131% is a little high. I hope that you all are having a good week and you have a great weekend.